Hi everyone, in today's video, we are diving into the exciting world of Spring AI and how you can use it to chat with documents. Imagine having an intelligent assistant that can understand and respond to queries based on the documents which you provide. So let's build it. For this demonstration, I'll be using locally running large language model Llama 3. We need Ollama to run local LLM. If you want to know how to set up Ollama, please follow the link in the description box. Let's see what are vector databases. Vector databases are specialized data storage systems. They play a crucial role in modern AI applications, enabling efficient similarity searches, clustering, and other vector-based operations. Let me give you a more relatable example what a vector database is and how it operates. Everyone must have used color picker. We can pick any color and we get 3-valued vector of RGB. And the colors that are similar will have similar RGB values, and the colors that are very far from each other will have very different RGB values. We apply similar concept to our documents. We split our documents, and for each section we create vectors, and we store the text and the vectors in our vector database. This is a sample document which I created about social media. So for each section of the document, it will create a set of vectors, and the corresponding text with the vector will be stored inside the vector database. When we get a query from the user, we perform the same process. In this example, the user is asking, what does the future hold for social media? We will pass this query to the same API and get the vector representation. Then we query the vector database about the documents that are similar in meaning. And the vector database finds the documents and gives us the corresponding section of the document. If you have liked the content so far, please like and share it with your friends. Having covered what vector databases are, let's see what is RAG, or Retrieval Augmented Generation. Retrieval Augmented Generation is an approach that combines the strengths of retrieval-based and generation-based models to enhance the capabilities of natural language processing systems. It integrates external knowledge retrieval into the process of text generation, allowing the model to produce more informed, accurate, and contextually relevant responses. Let's see how RAG works. The first process is query encoding. The input query is encoded into a high-dimensional vector using an embedding model. Document retrieval. The query vector is used to search a pre-built index of document embeddings. The retriever selects a set of documents whose embeddings are closest to the query embedding. Contextual information integration. The retrieved documents provide additional context and knowledge that the generator uses to produce a more informed response. The last process is response generation. The generator takes the input query and the retrieved documents as input. It generates a response that integrates information from both the query and the documents, ensuring the output is more accurate and contextually rich. Once we receive the documents from the vector DB which are similar, we will send the documents to the large language model for generating the response. Now it's time to practice what we have learned so far. To start with, we will go to Spring Initializr website and we'll create a Spring project. We'll choose 3.3.2 Spring version and Java 21. Let's add dependencies. We'll use web. And after that, we'll have to use AI. We will use Ollama as we are locally running large language model, which is Llama 3. Now you can generate the Spring project. This is a Spring project that I made in the previous videos. I will be creating the resource for me. The content, I'll name it info.txt, which will hold the data against which I will be raising the queries. This is some dummy content which I made on social media. Now let's head on to Spring Boot properties. These are the two key value pairs that I had. You also should have it if you are running Ollama. Now I will add few more properties. Spring AI Ollama embedding enabled. I'll keep it as true. And then I will have to specify Ollama embedding model. This will be same as Llama 3 with 8 billion parameters. And I will specify the path of my resource, which is info.txt. Let's create a RAG controller. I'll declare it as REST controller, and this class will need some dependencies. Some of them we had already used, like chat client. Then this will also have embedding model and vector store. Let's declare vector store also. Template I will be using to manage the system prompt. And this resource is nothing but info.txt. I'll set up the value for this. Value class path info.txt. So I am reading the value from the file.path. Okay. Now inside the constructor, let's initialize chat client. I also need the dependency of embedding model, chat client builder, okay. Now we will initialize embedding model and we will set our chat client with the help of builder. Builder.build. Okay. Now we will be creating the post construct. Before invoking our endpoint, we will have to specify what all things have to be there. So we have to specify how vector store would get created. We will be using simple vector store and pass embedding model. Next, we have to read the data from info.txt. For that, we will be using text reader, and after reading it, we have to split also. So we will be using token text splitter to split the data, and then we will store it into vector database. Let me initialize token splitter. Now I will be ingesting the data of info.txt with the help of vector store.accept. Now this is done. Let's initialize a system prompt. Let's create a system prompt. I want my prompt to be very strict. I don't want the large language model to hallucinate. It should only give me the answer which is present inside info.txt, and it should not fabricate the answers to me. And if it doesn't know the answer, it should just say, I don't know. And I will have to provide a placeholder for the knowledge base, which is documents. Let's see how are we going to populate the documents placeholder. Let's create a post mapping. I'll name the endpoint as RAG, and let's create a simple method. It will return chat response. Chat response will be of the type declared inside the model package. It should accept query request. Okay, let's now implement RAG. The first step is retrieval. We have to retrieve the relevant data from info.txt with the help of VectorDB. We'll use vector store and perform similarity search. And let's pass the query. Query will be what we got from the user, request.getQuery. Let me correct the formatting. Okay. Dot stream. Inside the map, you will do document.getContent and collect the response. This is what we got from the VectorDB. Now the next step is augment. Using the response that we got from the VectorDB, we will add to the message that we are sending to large language model. We will use the system message, and inside the system message, we will augment the relevant docs. We'll create a system prompt template. Template.createMessage. And let's add documents. Remember, documents was the placeholder that we declared in our template. And what is it that we want to fill inside documents? Relevant docs that we just fetched from the VectorDB. So this will create the system prompt for me by adding the relevant docs inside the documents. Now the last step is pretty straightforward, which is generation. We'll create a user message using the query which we received from the user. New user message, request.query. Now we'll create a prompt having system message and user message. List of system message, comma user message. Let me import list. And now we will use chat client to send our prompt to the large language model. Chat client.prompt. Inside prompt we will pass the prompt and call. Now we just have to create the chat response. And inside this chat response, we have to populate the response that we got from large language model and return chat response. That's it. We'll set response from response.content and return chat response. Let me do some basic formatting. This is done. And now it's time to start the application and test things out. So these are the 3 steps: retrieval, augmented, and generation that we have performed. Let's start the server. Now the server has been started. This is an endpoint which I had created /rag, and I am asking what does the future hold for social media. Let's see what I will get. Now, according to the knowledge base, the future of social media is likely to be shaped by ongoing debates and evolving needs of users. It gave us the response, but how do we know it is coming from the info.txt or not? Let's see what is the data in info.txt. So there is a section on the future of social media, and the lines are somewhat same what we are seeing in the response. The future of social media is likely to be shaped by ongoing debates. This is correct. If you have liked the content in this video, then please do like, share and subscribe to the channel.